Everything starts with a representation of numbers. You've encountered a lot of numbers, and you know different ways of representing them. But the ways you are familiar will give you context. Obviously, you know how to count, and you know place value. You might have worked with computers, in which case you know that there's even different counting bases. Everybody knows a strange counting base, and that's time. Look at this clock. There's minute places, and there's hours places. The minutes are base 60, and the seconds are too, while the hour places are base 12, or even base 24. If you know how time works, then you can certainly handle a lot of different representations of numbers. You just need it to be framed in a context you understand. Numbers are meant to be an adjective for a noun. Think of 1 plus 1. That might be 2 if we're talking about abstract values, or if the ones are referring to the same what. But what if the context is that I have 1 cube and 1 stick? I have 2 things, but I don't have 2 cubes or 2 sticks. If you're adding things of different place values, let's say 205, what do you get when you equal those out? You get 205. The numbers here are adjectives and the nouns are the place, 105, which would be the ones place. In a similar way, 4 is less than 6. That is, until you're talking about 4 dimes is less than 6 pennies. This is a place where context matters. Context really gets important when you're working with more complicated numbers, such as 3/4. Is this a whole value on its own, or is it a ratio? Math keeps getting more complex, so the context keeps getting more important. This matters because you can miss a question on a test if you accidentally add 5 and 12i, or if you accidentally add 2 numbers that you were supposed to subtract. I'm speaking from my own history here. This is context, and when you're working through a math problem, the meaning of the numbers can get lost. Keeping the context obvious from start to finish can help you prevent silly mistakes. And silly mistakes is what can make you feel bad at math. Representation can even trick you into thinking you don't know how to solve a problem. An example by Professor Herb Gross goes like this. Suppose eggs are 254 carton. Remember that? Then how much is 10 cartons? Like I said, you know math. That's 25/40. But what if I change the form and said that in an inch, there's 2.54 centimeters? How much is in 10 inches? If the fact that you don't remember or feel comfortable with the metric system, and that causes you to fret and not know how to approach this question, then you don't have a problem with math. You have a problem with representation. You have a goal that you want to reach, and math is going to help you get there. You might be closer to that goal than you think. You just need to reframe and retain the context of those numbers. That's going to benefit you as you learn math.